lecture. This is today we'll talk about something new, content about maps. This is the last lecture that will actually be in the exam. So on Tuesday we will be reviewing your projects, and I haven't heard back from Aaron, but he was planning to talk for 20 minutes about tensor visualization, the stuff that he couldn't get done in his lecture. So if that works out, fine. If not, we either make it a short lecture next Tuesday, or I will chat a bit about set visualization and text visualization, depending on whatever we think feels good. But in terms of the exam, this is kind of the last lecture that you have to care about. Any questions about your projects before we go forward? You're due on Friday. Yeah. So if you have any questions, just come to my office hours afterwards, or post on Piazza. Okay, so today is about maps, and maps are, of course, very important. As I already mentioned a couple of times, maps are, while they are important, they're commonly overused. But today we will simply talk about everything that you can do with maps. So maps are essentially a type of spatial data. So you have locations and or position on a sphere, but of course we think of them not in the same way as we would think of a tissue slice or something like that you look under a microscope, but we have a much more familiar understanding of maps. And so you should really use maps when spatial locations are paramount. So for example, if you want to visualize distances between two places, of course a map is a great idea. So the tasks that you can address with maps are finding a location, finding a feature, for example, finding a county, a country, a city, a street, a mountain, a river, or whatever, finding a route, connecting two points, or finding a path, identifying associated attributes with locations. So for example, the elevation at a certain point, whether it's land or water, the average GDP per county, per country, anything like that, how many people live there, whether the people that live at this place own a gun, and so on. They compare, and of course you want to be able to compare attributes between locations and features. So you want to be able to understand what distinguishes New York City from San Francisco, for example. Okay, so we briefly, when we were talking about D3, we talked a bit about map projections. So here's just a couple of other examples and why map projections matter. So why do you use projections in the first place? Well, we do want to see a map typically on a flat surface. Of course, globes are great, and playing with globes are great, and there are circular displays, or spherical displays, but spherical displays are rare. They're not very high quality typically. So what we kind of have is either we have print, then we need to project the map, or we have flat screens, and then we also need to project the map. So, and the challenge here is, of course, we have a sphere, and how do we actually map that sphere onto a flat area? And the answer to that is projections. And there is no right projection or no wrong projection, or all projections are somewhat wrong, of course. There is a trade-off between all of these various projections, and depending on what your goals and what your tasks are, you need to really think about which projection is the right one for you. The relevant attributes that you should think about is the size of the area that you represent, so whether a projection is faithful to the area, whether the shapes are undistorted, whether directions hold, whether the bearing holds, whether distances are faithfully represented, and whether the scales are equal. And so, as you might have noticed, I like XKCD, and so here is I'm not going to give you the time to read this now, but here is what does your favorite map projection say about you? So you can look through them, and this is pretty comprehensive, let's put it this way. Okay, so the most familiar projection is probably the Mercator projection. So here the idea is really that you project the sphere onto a cylinder wrapped around the globe. It's a conformal map projection, which means that angles are preserved, which implies that you have constant bearings. If you want to sail somewhere, this is a great map to use. and you have a constant compass heading. And so like this is also the reason why it was developed. It was developed for people, for seafarers, for sailors. This is like how, probably like, depending on your age, but I still saw these kinds of maps like very commonly in these large posters in my school. Typically this is what, if you grew up like me, this is what the world looks like to you. Maybe this here might have been cut off so that you can focus on the relevant land masses, but yeah, so this is kind of the typical map projection. And there's a lot of things wrong with that. One of the benefits, however, is that it also like preserves things like circles, so the shape of structure. So this is a Mercator projection of Mars, and so the circular craters still map to circles. So why is it problematic? It's kind of like, it's not problematic if you want to use it to navigate at sea, but it's problematic when you want to teach students about geography. You have like this massive distortion of area distant from the equator. So it's unfair to the global south, making places that are mostly trees, snow, and better off white people look huge, and the places where most of the world populations live look puny. And so another long paragraph. Mercator works really great if you're, say, Ferdinand Magellan looking for a compass bearing that will take you around Cape Horn, because all of the latitude and longitude lines and angles in between lay out nice and straight on the map like we experience them in real life. It also works well if you Google and you want a map image that you can neatly slice up into little squares that your server sends to customers' browsers. North it goes up, your hometown doesn't look squished or slanted when you zoom into it, and everybody's happy. So Mercator projections are really good for this kind of stuff, and Google Maps nowadays, at least Google, the satellite images still use this technology. The maps, the actual map images, Google Maps doesn't use tiling anymore, they use SVG. So this is like a tool by Google Maps, which they call the Mercator puzzle, which I really like because it gives you like an idea of what happens to two shapes as you move them along. So the goal here is, I might have shown this to you already, but the goal here is to map the shape here to the actual country. So what is that? Australia. It's Australia, yes. And you see what happens to a projection. So this one?
China. Brazil. That's Brazil. It's got to be Brazil.
Yes, Brazil. But look at how it... Yeah, it's not a perfect fit here, but it's Brazil. So this one?
Greenland.
Yes. And we imagine, of course, Greenland to be much smaller. This one? It has this like straight line, so it's probably not in Europe. Okay, well, anyways, just like play with this. This here, like, is Mexico. Mexico is roughly the size that we would explore. Is it Mexico? Yeah. So play with this to get a feeling for what happens to Mercator projection. Yeah, so Mercator projections are of course great if you're like, if you look at a world map, they're not great, but if you look at a city, they're totally fine. So latitude, longitude, like you could simply just take your compass bearings, your GPS bearings or your GPS coordinates and plot them. That's what you can do, for example, without having an underlying map. If you have enough location data, you could simply, like, if you have for every single picture that was ever taken on Picasa that has location data, you would plot that and you would get something like the shape of the Earth. Without using a projection. The problem here is it doesn't preserve angle, it doesn't preserve areas, and things are pretty squashed. So it's not really a great way of rendering a map. A special case are azimuthal projections. So here you project onto a plane tangent to the Earth, and the angles are correct around the center point. So like the angles out of like the North Pole in this case here are correct, but all other angles are not. The great circles through the centers are straight lines, so great circles are the shortest routes connecting 2 points. and radii correspond to the true distance. And so this is what you would see sometimes in an airline map that's centered around the hub of an airline. I would say this is more like a map for special cases. So here is like how that looks like if you wouldn't center it on a pole. So this is kind of like a little bit unfamiliar. But if you have like a map like this, it might make sense. It gives you like a nice overview. So this is from like a while ago, how people working for Time, Life and Fortune, how reporters traveled and where they went to. Yeah, that makes kind of sense. The Winkle triple projection is a modified azimuthal map projection, which is averaged to a cylindrical projection. And it tries to minimize three kinds of distortions: area, direction, and distance. And this is kind of what you would see in modern textbooks. Like if you taught geography now in school, this is the typical map that would be used. And it's endorsed by the National Geographic Society, and as I said, it's used in textbooks. So this is like how the world looks like on this map, and of course this kind of looks okay to us. We have the feeling that this is a globe, and kind of the shape, the size and of things, they roughly correspond to the real size. It has some disadvantages, of course. It's not perfect, so you see things are a little squished. These would be all circles. You can see that the only circle that is completely correct is the one here in the middle, or even this one looks a bit squished. And you can see that like here, further out there, shapes are distorted to some degree. But like depending on your task, this is probably a good projection. The one that is important for like rendering the United States, the one that is commonly used for the United States, is the Albers equal area, which shows the areas correctly but distorts distances and shapes. So yeah, this is like one of the biases that we kind of have is, of course, like as I mentioned before, because of like things like McArthur projection, we get this idea that Africa is, for example, pretty small, but you can in fact actually put the United States, Argentina, whole of Western Europe, India and China into the continent, and it's still smaller than the land space in Africa. So we've talked about these different projections, but it turns out, and I mentioned it earlier, that depending on your scale, depending on what window into the world you're looking at, there's not one global projection that works best for all. So people came up with these cool tools where you can actually navigate around, and it would dynamically change the projection. So here is this projection diagrams. Here is the Hammer projection, the Lambert projection, Albert's conic. Then here we have McArthur, Lambert, azimuthal, and I can take this point here, and like here we have longitude, and then here we have zoom, and you can see that the projection, when I hit like one of those borders here, the projection changes. So you can see like going in now is the Albers conic, and then when we go up, it also changes the projection. Then the further we zoom in, here you can see a big change again. Now it switches to McArthur. So this is of course not the only good solution, but this is a good solution, and yeah, this is what you would have to think about if you really wanted to do a comprehensive GIS system. We talked about the projections in D3. There's some people that developed D3 that were kind of like projection nerds, so they implemented probably every single conceivable projection for D3. And yeah, you've played with this, so I'm not going to go into detail. This video here shows you like what you can do if you unfold the Earth. I'm just mainly showing it because it's pretty cool. So here, there's no projection, it's just how do you slice, like a, let's say, a paper globe. This one slices in a way that only in the oceans there are slices, and now in this case another ocean slice, and this is now only the land mass, or mainly the land mass being sliced. Okay. So, software for map software and navigation software, of course, you've seen this. OpenStreetMaps and Google Maps, they're great. And we talked about those, that you could use that, for example, for a project if you kind of want to annotate something on top of YouTube autoplay. Well, okay. So yeah, if you want to if you want to create a visualization that is really where you want to, let's say, visualize the best restaurants in a city or something like that, you would use like a map like this versus using an abstract map if you want to say visualize political voting. And you can overlay on top of these. Of course, there's others. There's professional GIS systems and so on, but these are kind of the famous ones. And then you can create those mashups. I talked about D3 maps a while ago when we were talking about D3, so I'm going to essentially skip over this. About navigation, so there's two different ways to do navigation. So either you can show it directly in a map, as you can see here, or you can do this abstract description. So like this would be like for my old office to my favorite bar in Cambridge. I could either walk or drive or take a bus. But anyway, so you can see like here would be like the list-based description, and here would be a map-based path shown here. There is something else though. If you think about how like we as humans describe a route, a path, it's a little bit different from those two. So we wouldn't give people a list of things, but we would draw these abstract maps, like essentially highlighting the most important features, compressing long distances, and so on. So we are pretty good at doing these things. And so people thought about, can we actually like emulate this? And actually people tried. So here's a map that shows you the route between Madison and somewhere in Illinois, somewhere in Michigan. So instead of showing you this actual map, they simplified it and they kind of zoomed into the important regions, and they added like what is really the things when you drive, where do you have to make decisions. Those things are emphasized, but the straight lines here are like, this is of course not a straight line, but it's not important really to keep the context of how the highway winds across a river or something like that. And it's really, this is also about careful labeling and maintaining an overall orientation. So this was published by Manish Agarwal from Berkeley, and actually Microsoft, if you still remember that Microsoft also had a map software, they did implement this a while ago. It's now defunct, it doesn't work anymore, and it didn't get a lot of popularity. But it was there, so you could simply like ask for human-like directions. Okay, so this is the basics of maps, and now let's talk about how we encode data on top of maps. And the a key thing is of course choropleth maps. The principle of choropleth maps is the area are shaded or patterned in proportion to a certain measurement, to a certain variable. And each spatial unit is filled with a uniform color or a pattern. So here are a couple of early choropleth maps. This is a map of France and the various districts in France. And what does it actually show? Population in France, I think. Illiteracy, oh yeah, you're right. My geography, like Paris isn't around here, so this is Paris, I assume. This is a very early example. These are the ones that you're used to. Here you see the votes for Kerry versus Bush. And as we all know, Bush won that election and it looks like he really won a landslide. If you plot this as a bar chart instead, in terms of the popular vote, you can see that the margin was pretty slim. And if you plot the amount of red and blue shown on the map, you see, of course, like that. This is the reason why it looks so like overwhelmingly going towards Bush, and that's of course because the population doesn't map to the area. So here would be this is like. In this case, we only show like which districts or which voting districts did any of these candidates win. Here we actually they're actually showing the percentage. So if it's slightly red, you know that the Republicans won, but you also get an idea of by what margin. So this is kind of like a little bit more accurate. So you can see that there's like a wide, essentially. Here, it's still an overwhelming majority for Bush, but it's not as like massive as here in the middle of the country. If you adjust this by population density, the picture gets a little bit more, let's say, intricate, and you can see essentially that the urban areas cluster the Democrats, and with the exception of California and some southern states like Texas, and of course Utah and Arizona, we can see that the urban areas also go Republican, but that otherwise the urban areas tend to go Democratic. So here, this is really, in this case, the ink is proportional to the data. So this is like this idea of data to ink ratio, and let's say, not to lie with visualization, this kind of shows you a faithful distribution of how people voted. So we're simply considering population density. Of course, there are 3D versions of that, and 3D in maps is not by default a grave sin, I would say, because you have this spatial dimension, but you have to be very careful. So you can see, this area here, the very dense northeast, is really hard to parse what exactly happens. There is another 3D example later that is, I think, pretty well done, and that's a decent map. This is a choropleth map that I just recently saw on Twitter. It doesn't really have any visualization, or not a lot of visualization value, but I just found it really cute. Choropleth maps, instead of districts, you would have little bear shapes. And this is the density of bears in Finland. So, kind of a recursive map. This is an interactive map where you can dynamically map things like, let's try Salt Lake. So you can see what is the median income in which area. So you can see, wow, people around the University of Utah seem to be pretty rich. But I guess that's also because not a lot of people live in this.
No, that's really poor. It's really poor.
Oh, it's really poor. So that's students.
It's probably because of
Yeah, so this is probably you guys. Okay.
That still doesn't seem right.
Yeah, and so this seems to be the avenues are a little bit more high income than Harvard Yale is, and Yale Crest is a little bit more income, and so on. So yeah, you can play around with this if you're interested. There's, I think, other things like owner occupancy. So this, I would assume that this again, only 4 searches remain.
It's ironic that it charges you. Talking about income inequality, and they want money from you for running the query.
So you can see that in the city, owner occupancy rates are lower, which is of course something that you would guess. People kind of tend to rent more in a city. I'm still surprised that it's like 20% only owner occupancy within the city, but yeah. And I can see that like in the countryside, we're like at 70% or 80% owner occupancy. You might have seen these like baseball territories or sports territories, and I think they're really well done. And so these are maps of where in the United States and partially also in Canada, where people associate with a certain sports team, a major league sports team. And so how they did that is they scraped public Facebook profiles by location, and then they looked at what are their favorite teams. And it gives you like a kind of like interesting insight. So for baseball, you can see that it's pretty regional. So New England is of course Red Sox territory, California is Giants, or Northern California is Giants, Dodgers, and then here we have 3 different teams of course. And it, like the thing about baseball is it doesn't seem to be like, there's not one team dominating, maybe the Yankees of course, like it's hard to tell. You can actually look at the interactive version.
Yeah, I'm curious, since Utah is kind of colored gray, does that mean it's Yankees or something?
Yeah, I don't actually.
Or does it just mean they don't care?
I guess, here we see. So partially Red Sox, partially Yankees. That's, yeah, probably because Utah doesn't really have like a clear favorite for a Major League Baseball team. So you can see that kind of Yankees are kind of dominating the areas where there's not a lot of teams, but other than that it seems pretty regional. And if you look at other sports, it's not like that. So the Lakers here are very dominant in terms of basketball. And so like Lakers are in like violet. And the thing that I find interesting that
Canada, look at that.
exactly,
I like
that even Canada prefers the Lakers. I'm not sure whether this is still true, but
Saskatchewan.
and like interestingly, of course, Quebec rather would have an American team as their like fan base than Ontario. Yeah, but that kind of like, and I'm not sure whether this season is actually still like that, but. Of course this fluctuates, but it's interesting to see that there's some teams that dominate a sport in terms of like their, let's say, market outreach that get like a nationwide fan base.
Be interesting to see if they had data back from like when Michael Jordan was a really
Yes,
big, for
that's true. That would be really interesting to see. And yeah, there's of course football and so on. Here is a map that. Of the nation's well-being. I think that's like there's like various indices like learning or stress. And stress seems to be pretty high in Utah. Happiness seems to be pretty high in Utah. Depression is not so high. Health problems, you can zoom in. Cholesterol, diabetes, obesity, all pretty low in Utah. Work environment seems to be good. Fruits and vegetables and so on. So like, what really makes those maps interesting is of course the wealth of data, and what makes you care about them is of course that you can always look out for your, like the areas that you find interesting where you've lived.
Where do most of the data sets for these come from, by and large?
This is like probably census data. But this can be anything really. Like you can scrape this data like in the sports cases from Facebook, or this is probably census data or survey data, some national surveys. And I'm sure that this, yeah, it says here it's a Gallup poll with 1,000 randomly selected adults each day.
That's a pretty good sample
Yeah.
size.
Are these all by and large, if not D3, then something within, Java and JSON, JavaScript, etc.?
Well, the ones that I'm showing you here are web-based. I think typically, like either web-based or print. There is, of course, these like if you're a utility company, you would use a professional GIS system that has all this like information of who owns the property, where are the pipes, and so on. But for, let's say, consumer-facing stuff, it typically is web-based. So you guys probably remember this one. I just wanted to come back to this because like there was, I didn't discuss it in detail when we were reviewing the exam, but there was quite a bit of discussion, as I mentioned, on Twitter. And so like this is a map of the population of the United States. And this is essentially the map that you saw where the GDP was split in half. And so I just pasted a couple of reactions on the internet to this map. So this one is the one I really like. It's really just a map of the population. So like here you see RSAT users, so subscribers to multi-tiered living and consumers of furry pornography. Of course you would see these patterns because it really just shows population. So this is like one of the grave sins of working with maps. And of course, like targeting urban areas will get you more people. So here is a nice, I think, 3D map. This is like where we live, a population map. And so like here, I think again, similar to the case we had with the yield curve for loans of the New York Times. Here they make like careful use of 3D, and it gives you like a better impression of what is happening than it would if you just shown this as a choropleth map. So you can clearly see the urban clusters. You can see that again everything around New York is like very like high, and you can see the area around Los Angeles is the second largest, and so on. So and I think this is a pretty well done map. There's a lot of annotation, so it's a very carefully designed visualization. Then going back to this this map, the 50-50 map. So there's a couple of comments that I would like to read out to you guys. So the problem here is not that it could be interesting to see population density, but the claim is that something other than population density is revealed, which is simply not true. Why not make a chart of population density instead? This incredible map shows you where 50% of the people in the US live. If this were really about GDP, it would be per capita. That would be interesting. Income per capita is certainly higher in New York City than in Dallas, for example. But how do New York City and LA compare? What about other areas? And how does income compare to cost of living, and so on? So like here it's really about like this is much more complex, and this map is showing something, and it's true. It's true what it shows, but it is not faithful to the idea that it represents. And so here is like another comment by Alberto Cairo. He says simplistic graphics like this, only one or two data points, no nuances, exceptions, details, are the equivalent of just writing just the headline, when you should be writing the headline plus a complete news story to provide background information. And another guy, Stephen Few, who is kind of like a visualization blogger and consultant who is kind of famous and notorious for tearing up InfoVis papers. In our modern world of news aggregators, few people read beyond the headlines. Knowing a few sound bites and bullet points is what passes for being informed. Few take time to think beyond the superficial level. Most producers of infographics encourage this through their designs, in part because they embody this in their own thinking. So he's essentially ranting against design versus faithful data representation. And so this is I think this one is actually like a smart way of showing what this map shows you. So like this is what the map implies, where the index where economic activity happens in the countries. Like here we would have the left half of the country, and here would the other half of the country. And it implies that there's this gap, that there's this, okay, these guys are actually doing all the work and these guys are slackers. Whereas in reality, it's probably a curve like this. That is why that map is really not a great map. Okay, so let's talk about something that is also about geospatial information, but not just map. So the design critique today is about gap matter. You've seen this in the first lecture. I've shown you a video of Hans Rosling presenting it. But if you go to the latter link, you can actually play with it for yourself.
could use this to make some pretty fake headlines about data. Strong correlation observed between the number of billionaires and the number of infant mortalities in Afghanistan.
Yes. But the thing is, of course, that correlation doesn't imply causation.
Yeah, exactly.
Okay, so let's talk a little bit about this. So what is the data that we see here?
It's like every survey data set ever taken.
Yeah, so it's these like, let's say, economic development indices, any kind of like demographic data, any kind of like things that government statistical agencies collect, like how old do people get, how frequently do children die, what is the income per capita, and so on. So based on government statistics. What else? So
the population in terms of the radius of the sphere.
so yes, but that's one option, right?
Oh, yeah, look at that. I didn't even notice that.
Yeah, so the other data source I would say here are, of course, like the countries, but also the geographic locations. So this, the geographic locations, according to continent, would be kind of like a categorical assignment, and that's what the colors actually mean, but you can actually also switch those, whether it's things like landlocked or G77 and OECD countries, and so on. So, like, why do you think this chart, like, what are the various options that you have here in terms of interactivity? What are the key aspects here? Time?
Longitudinal nature.
What was it?
The longitudinal time.
Yes. So like, we don't only have this data set for a single time point, but we have it for a lot of historical data going back to the 1800s. And how do we like compare different time points?
Visually, never trails is the great
Yes. So
feature.
the feature that you can actually use to compare across time is this trail thing here. So you can essentially like select the country, and then you can see like for every single time step where that bubble was. Of course, it does only tell you something about the selected country, but I can select multiple countries, so I can compare Canada to France to, let's pick something, Korea. And so you can see Korea remains pretty static here until the 1920s, and then suddenly it follows the path of France and Canada. So you can see that the child mortality in Korea is pretty similar to what you see in Canada or France, but income is not. So it doesn't seem to be like strongly correlated to income. So what would be the alternatives that they could use to compare these time points?
Line charts.
They could use line charts, yes, but what would be the disadvantage?
Space.
Only one dimension on the line chart, but here can have multiple dimensions.
Exactly. So they work well for if you want to just look at the symbol indicator, but if you want to see the correlation between two indicators over time, it gets tricky with line charts. And of course, what would be the standard technique that you could also use here instead of like these lines? Well, you could do small multiples. So you could pick, let's say, 6 or 7 or 8 time snapshots and plot them as individual small multiples. So another feature here is the play feature. What do you think about that?
That's pretty good.
can make it faster. No, slower. Yeah, so this is kind of like a data movie, essentially. You can see it moving around. Other interactive features that we didn't talk about. Did you find something?
You can change the
So
size.
Flickr view, if you're looking at,
The Flickr view?
if you, I think it happens if you click on the geographic regions on the map.
Okay. Ah, that. Oh, I didn't know that, yeah.
If you have a large data set of many different countries, if you click on a certain region or something, it will highlight the ones.
Yes, that's interesting. I didn't see that. Other interactive features you found?
You can change the node size by
Yes.
some criteria, and then you can size how it gets proportional, so you can have a lot of control over what the nodes look like.
Yeah, so this is kind of like one of the strengths of this tool is that essentially like you have three visual variables or three ways to encode data, and you can essentially define dynamically whatever each of those means. So you can like pick each like indicator here from this long list. And you can pick the same for the x-axis, and you can pick the same for the size. And you can also like select countries here individually, and so on. There's also a map view. And of course the map view cannot show you the correlation between two items or between three items, but only two items, so here you have the geographic context. One thing that I found interesting here was CO2 emissions per person on average, and if we increase that and go to that time where we have that. So kind of interesting in the context of the climate summit, so we can see that the circles are not super efficient at communicating this, but of course the United States, Canada, and so on are like big CO2 emitters, but especially the Middle East, there's a lot of CO2 emissions. And if we look at this in the chart, and we switch off the trails, and we plot that versus CO2 emissions versus income per person. So I don't know why it doesn't scale quite right, but you can see that there's kind of this linear relationship, and the biggest emitter is Qatar per person, and the United Arab Emirates and Kuwait, and then Luxembourg and Brunei, and so on. So what do you think generally about this visualization?
It's good. It invites you to play around with the data set. There are a lot of different things you can see. It gives you a lot of control over the variables you see, how you display them, and ways to animate them.
Yeah. Other opinions? Do you find it easy to use?
It's a little clunky.
It's
There's
a little
lot
clunky.
of data, like, I think it takes a long time, like sometimes the ticking will take a little bit of time to load each new thing because there's just so much going on, so.
Yeah. I guess the clunkiness can be attributed to this being like a little bit older. We're kind of used to the slick D3 based visualizations. I think this one is still a Flash, and it seems to be from 2008. So that like nowadays it would probably look a little bit better if you just redid that. Any other opinions? Okay, I think personally it's a great tool to get people to play with these data sets, and it's like if you want to explore these relationships. Of course, this is the Gapminder Foundation is not about visualization, it's about public health, like educating people on political issues, and Hans Rosling has these many talks on, for example, on TED, where he simply clears up misconceptions about how we perceive the world. So, for example, one of his points is that we're like not in a phase of population growth per se. It's just like essentially the only effect that still makes our population grow is that people age, but the number of birth actually already started to like level out. Things like that you can see with this tool. And yeah, I'm sure there are his videos in here, but I'm not going to wait for them to load. Okay, so let's talk about contour maps. Contour maps are important to show continuous variables. So there's a lot of relationships, of course, to flow visualization here. So I'll keep this short. So here's an early contour map. Lines of equal magnetic declination, of course, important for navigating at sea from 1701. And then here's an early map, again relevant for navigating at sea, is Halley's wind map, so the major wind directions in the Atlantic. And you've seen this one before. This is this interactive wind map. Oops, the link is dead. Okay, it looks like my internet doesn't work. It's not so important, but you can see this dynamically change. This is a real-time map of like all the wind in the United States, and you can also go to some historic storms and so on and explore them. Contours are of course also used to show elevation. This is kind of like if you like to hike, you've seen these maps quite a lot, and Aaron talked about this. What are all the benefits and drawbacks of these maps? And so they're like, if you pay close attention, you can actually see a lot and get out a lot of those maps, but it's hard to tell whether something is a peak or a trough. So there are symbols that indicate that, and so on. Here is an example that shows you the projected path of a hurricane. Which was it? A hurricane. I don't remember exactly which one it was. Projected path of a hurricane. So this is really interesting because it shows you, well in this case it doesn't, but another map. I hope I have that. No, I don't have that. So another map like that. So this shows you kind of like the projected path of the storm, and here you can see like the hurricane force winds, tropical storm force winds. But another map by the New York Times also showed you like the uncertainty, like what is the area that would be the actual path of the storm, that like a likely path of the storm. And this is of course what we also see on this map is population density, because of course if the storm were to hit in an unpopulated area, it would mean less to us than it does if it hits to a populated area. Okay, so the next thing I wanted to talk about is cartograms. Cartograms kind of like take an issue with this, like if you want to plot the data onto a shape on a map, that you simply get this issue of like the not densely populated states being overemphasized and so on, and cartograms try to remedy that. So the idea here is to scale the distance or the size by data. So instead of showing you a faithful shape, you get something that somewhat resembles an original shape, but is actually scaled by the data. So here is distances in terms of travel times between the various areas. So how long it would take you to fly from one area to another. And you can see, well, this is somewhat resembles the United States, but not quite. Here is another one that is scaling the area by data, that also scales the area by data. In this case, it's Elvis concert attendance per state. So you can see Texas is big, California is big, Utah not so big. Of course, it's population. But so the idea here is really like we show like a pixel per data point, and we give you and it still gives you an idea of the shape and of the location. And you can see, of course, the Midwest here is rather small. So here's are a couple of examples of this. So this would be like a regular world map. This would be a cartogram scaled by population. You can see that Canada essentially vanishes, whereas China and India are, of course, really big by GDP. So this one might get a little hard to read, especially if you want to locate like a country in Africa. But yeah, so you get an idea of like, okay, Japan actually, I don't know when it was done exactly, but Japan in this map actually looks almost as big as China.
France is amazingly huge, so.
Yeah.
And Germany too.
Yes, France, Germany, like the United States are kind of like the big industrialized countries. And of course Alaska also looks pretty big. Child mortality. A different map, of course, here Africa dominates and India. Greenhouse emissions, so like what we've seen in the just seen in the Gapminder, you can see that Africa and also Southern America don't produce a lot of greenhouse emissions. And this would be Kerry versus Bush in 2004, so a similar map as we've seen before. But this kind of like is probably, like if I just showed you this, you would say this is maybe a Rorschach plot, but not a map of the United States. So you can kind of like tell what the problem is with these maps is that unless there's like, yeah, if these strong distortions, they sometimes make shapes really, or areas really hard to recognize.
Do you know much about how they do this distortion technique? Do they take the set of edges of, for example, the shape files from each country and then
I don't actually
find what
know.
you're projecting?
No, I haven't read the paper in detail. There's these rectangular cartograms which do something similar, but they kind of like make it more discrete with rectangles. So the word population in the rectangular cartogram. And here, this is kind of like a more like this is just really fitting squares to approximate locations. So this is not really trying to preserve shapes anymore. But you can see that we have here, this is the Los Angeles district, and then here we have the New York districts and so on. And you can see Cook County is of Chicago and so on. So like, yeah, having some idea, like some notion of like where a square is to give you some geographical context, but simply like ignoring any shapes of the specific areas. Yeah. So there is an example of this recently in the, or not quite recently in the New York Times. So what your neighbors are buying, so like clothing and footwear, per capita spending, and so you can see like electronics, the United States, per capita is high, alcohol and tobacco, other countries catch up, household goods, recreation. Interestingly, Japan spends a lot on recreation. So these things are simple, and of course here are not a lot of countries, and you get like a rough idea of like United States is on the left by convention, and Europe is in the middle by convention, and Asia is on the right by convention. So you kind of get an association of where those places are. So another technique to show this, instead of like using these cartograms, are these necklace maps, and they are kind of like a compromise between preserving the area and like working things out, like what is the internet usage in Africa. That's really hard to see in this particular plot here, but what they do is they visualize the data in by the size of the circles, and they place the circles on what they call a necklace and move it as close to the specific country as possible. So here you see South Africa and so on. And yeah, they have a couple of algorithms of how to divide these divide these circles and how to make them like such that you can see where the location is. But of course you have to know about the name. So this is Nevada, and it's not obvious if you don't know that this is Nevada. It's not obvious. Of course the color helps, but it's a little bit tricky sometimes. So the illegal immigrants in the United States in this case. Okay, they also have one that shows you the Olympic medals of the Winter Games, and there Austria is pretty big, one of the maps, but
You don't have that one?
I don't have that one, no. Okay, so the other thing that you see a lot in the news is proportional symbols maps. So here would be, the idea here is really that you have a shape like a circle, and that you put it onto a map, and that you scale it according to some value. And so here again we have the Bush versus Kerry vote, and the vote margin. So is shown by the size in this case. And of course these bubbles will overplot. And so to counteract this, they use transparency. So you can see, like here, there's many circles on top of each other by increasing the transparency. But still, this gets a little bit tricky. So here, this one shows you Katrina's diaspora, which is of course centered around like New Orleans. And I think this is a pretty effective map because it gives you like a global overview, but it's really hard to read individual data points here. This one here shows you John Kerry versus George Bush in terms of domain contributions, and you can see like where people live that lean towards which party by these symbols. And of course people make fun of those, like the killer circles threaten America. Yeah, so they maybe are a little bit overused. They look cool, they show you some of the data, but they're maybe not the most efficient way of communicating on top of maps. So this one is interesting. I hope my internet works again. This is kind of a mixture of like a text visualization and the map. And so what are the surnames of certain regions? So if you look into the northeast, we can see like green, obviously Irish names. So what is the most frequent name in a certain region? So Murphy, O'Brien, Kelly. Then Spanish names are in red and the English names are in blue. And if you look at here, there's German names like Wagner, Schulz, Miller. And then
Where's Utah in there?
yeah, it's a little tough to navigate. So Utah would be about here, right? Smith, Anderson, Jackson Hole, so like more like, let's say, English names. And so as we go down in California, we get like the Spanish names to start to dominate.
Lee and Kim.
Yeah, Lee and Kim. And so the size here is of course scaled by population, so that's why we have like this less dense area in the Midwest. Another interesting project is Fat Fonts. So Fat Fonts takes the idea of using fonts to encode data, not only by their meaning, but by their, let's say, appearance. The font here is designed so that the number of 1 has half as much pixels as the number 2. And so on. So you can see the corresponding trends. So like 1 is looks pretty light, and 9 looks pretty dense. They can also do nesting, so that you can have like 489 in this case. And the idea here is that they could encode data that you can see like at the rough level. You can guess the value just by looking at the colors. But if you want to see the details, you can actually read what it actually means. So you can go to fatfonts.org and see things like the map of the world population, and some highlights here. It's a little tough to read. I think this is a cool idea, but it's probably a little bit more artistic than data visualization. It's great to have this as a poster, but it's not really an efficient way of communicating the data, at least in my opinion. So, like this is and map. Oops, it doesn't work anymore. Well, yeah, this map shows you distribution of racial and ethnic groups, and you can of course see the segregation into various districts in, let's say, for example, Chicago or in New York, pretty well. This one here was, and I mentioned it earlier, the visualization of addresses of gun owners. This was published after Connecticut school killings, and I'm putting out this map here. Like, you could really zoom in and see who of my neighbors owns a gun, because this information is public record. But in the past, you had to go to some obscure government website and query that, and then you would get a textual response. And these guys, they actually made this super accessible, and they published this map. And so I really wanted to bring this up because I wanted to ask you guys what you think about the ethics of that. Should you do that? Can you do that?
What's this? I think it goes similar in the vein of everybody's address, like arrest records are public too. You can publicize those, and there's a lot of websites that do.
Yeah.
I don't know. I guess it really depends on what your goal is with it, whether you feel it's justifiable or not.
Yeah, so the interesting question for me here is, the data is public. Is making it, do you assume, okay, since it's public, I can do whatever I want with it, or is making it super accessible to everybody a step where you also have to consider the ethics?
I suppose as long as it's anonymous, that...
Well, it's not very anonymous. Look up your neighbor.
When it's not anonymous, that's a problem.
You have to be
yes,
responsible.
addresses of gun owners, right, yeah. I see the problem here.
I mean, at the very least, these are the houses you don't want to go to.
Yeah, if you rob somebody.
I think the issue is that the idea of how data is public, not that it's visualized. The fact that you can go and get thousands of queries from this and then visualize it, that's the issue.
Yeah.
If you can query it like once every 10 minutes and only get one record, that's a little better. I think it's the fact that it's not, I don't really, I think it's fine they visualized it. It's the fact that they were able to get all that information,
Yeah.
so they could visualize it was the problem.
Yes, so it's really a difficult, gray area, I think, of visualization, like making it accessible, getting data that easily. And so there was a lot, this was a big controversy in 2013. So,
Especially like if you're one of the people in the middle of nowhere and you're the only dot, so it's like, okay, you want to go harass someone, you can.
Well, I think the intent is really meaningful here because, as I recall, this was right after Sandy Hook, I think.
yeah.
And so it was retaliatory. In that case, that's not okay.
Yeah.
If you're doing things out of spite, I think is a huge meaning.
Exactly. So you kind of have to, if you do data visualization of data that is interesting to the public, you have to kind of ask yourself the same questions as you would if you're a journalist. Is it really is this trustworthy? Is this ethical? Is this something that I can publish? Is this something that I should publish? What is the effect on people?
I think what's interesting about this visualization versus the fact that even though the records are public, with a public record you have to make a query, so you have to have someone that you are interested in whether they have a gun.
Yeah.
Right. Whereas this, you're not even I don't know whether, I'm not going to ask about any of my neighbors. I'm not even interested. But then I go to this visualization, and even though that was not the specific question I asked, whether they have it, I now know.
Yep. Exactly. So.
But doesn't this spark social change?
That's kind of I think that's the reason why they published it, right? They wanted to make people aware of it's not something abstract somewhere in where the shooting happened, but it's your neighbors and it's people that you know, and people in these areas and so on. So it's about, I think, essentially, I think, bringing it home, like putting it into context of what it means actually to own a gun and to live in a certain neighborhood and so on. So yeah, this was hotly discussed. I think one of the responsible people did resign over this and so on. So you can read about it in this blog post on the New York Times.
But in some ways, it's maybe not as ethically contentious as you would think, because there are other things, for example, property ownership, that maybe a lot of people wouldn't like to be public, but are in fact public.
Yep.
And you could get into trouble and spin those data in any sort of way you want.
Yeah, so there was actually, I know at Georgia Tech, there was a student group that visualized the salary of the professors. Because
And all of them got exposed.
no, it's like public record. So you won't be able to look up my salary because I'm not around long enough. But everybody else in the department, you can look up exactly how much they earn. And so a group of students in a visualization class in Atlanta last year visualized the salary of all the professors in the computer science department as their final projects. And needless to say, your faculty was not amused. Yeah.
Did they juxtapose it against like the janitors or something?
Yeah, so if you didn't know, the football coach makes most in Utah. Okay, flow maps. So flow maps show you essentially like how something flows. For example, in this case here, an early example, transportation of passengers in Ireland. But you like probably remember this one. I talked about this successively. How did Napoleon's march on Moscow go? So I'll not repeat this. But you've seen these in probably your high school geography textbooks. So things like trade between two countries is often shown as in these kinds of flow maps. And so this is the cotton trade in America with Great Britain before and after this U.S. Civil War. So you can see like there's a major cotton trade before that, and afterwards it's essentially gone. And so this is a map of migration. You have to wait, of course. So let's look at where do people from Wasatch County or from Salt Lake County move in and out of. So you can see that here we have two different encodings. We have the lines that show you where from, where to, so inbound and outbound in blue and in red. And then we have, of course, the color coding for the maps. And you can pick any kind of like area you want. And then typically, well, what we'll see is that there are some states like Florida, for example, that have a lot of migration, and the states in the West, for example, don't have a lot of migration. But just to juxtapose this, I also wanted to show you like a non-spatial representation of this data. So here is like, this is the New York Times has a great feature on this, on migration, and I picked out the Utah version. So I think this is people that, where people that currently live in Utah are from. And you can see that 62% of the people that currently live in Utah were born in Utah. Some of them were born in California, but like the West generally dominates, Midwest and West. And you see that other states in the South and Northeast, there's not really a lot of migration between the Northeast and Utah. And so there's like, for every single state, there's an example here. And so you can switch between migration, like where people have moved to, and how the people have moved, where people living in California were born, and where people in California moved to. So you can see people from California stay in California a lot. And Florida is pretty interesting, of course, because you can see the migration from, especially starting in the 70s, you can essentially see the snowbirds moving from the cold states towards Florida. So you can see people that were born in the Northwest, New York, or born in the Northeast, they kind of dominate the movement into Florida. But this is something that really only happened like around the 60s. Before that, people kind of moved more regionally. And so Western states typically move around within the West. But if you look at this, I think this personally, well, of course, we have additional data points here, like this is over time, and the other map only shows you for one specific time frame. But I also think this is kind of like more informative than the map, because it gives you like a better idea, and I don't think that the geographical location here is, again, that important.
What's the point of the interwinding in that?
It's a ranking, I think. Yeah, well, this one here is, for example, bizarre. Well, I guess here at this point it overtook it, but yeah, so this is a single state, and this is an aggregate, that's why it's not overtaking it. So I think it's still supposed to be a ranking. But yeah, I'm not quite sure. So this is a visualization of air traffic in France. So you can see Paris here in the middle. And it shows you flow. But it's like air traffic is not only interesting in 2D, but also in 3D. So this map has also a 3D component. So and this is like how you can interact with these airlines, these flights. Yeah, so you can dynamically assign the variables here, and then you can switch between altitude and longitude, latitude. So you can essentially tilt the area, and you can brush in both directions. And you can also dynamically do that here, so that you get a sense where the planes were landing. Yeah, so this just shows you like brushing of like around an airport. So in this case, this one is removed. Okay. Let me see, how much do I still have left? Yeah, we won't quite finish it, but not too far away. Okay, so the data-driven maps are what I mentioned about like plotting latitude and longitude. So don't use a map and render on top, but really let the data make up the map. There's a couple of things like that given the time. I just wanted to show you two examples. This is a zip scribble map. These are essentially like the zip codes in the United States connected from the lowest to the highest in one long line towards the center. So you can see how the zip codes are distributed, and you kind of can see the states pretty well. I'm going to skip this. I'm just going to show you this last video for today about sand dance.
Project Sandance is all about data visualization. How do we make sense of all the massive amounts of data around us? We use principles of information visualization to make it easy to understand the data and see the patterns within the data. So let's take a look at this data set here. These are actually 50,000 counties, but there's information, there's structure in this data. So if we actually map it onto a map, we can actually see the structure showing up. And when we actually shift to a histogram, the motion really helps you understand the data. And if we switch back to that, where they go back to. So we're going to actually look at some results from the recent election. So here what I'm going to do is map onto each county how they voted. And you can see actually the blue counties and red counties, and it looks pretty extreme. But actually it's much more nuanced than this. So if we look at a different palette here, you can see that, yes, it's blue and red, but it's not quite so extreme on either.
Okay, so the point here is really that the dots are not plotted on the map, but they're just plotted by the geographic locations, and just because they have enough points, it makes up a map that we can understand and that we can see. Okay, so that is the end for today. We'll see you guys next Tuesday. Good luck with your projects. We'll take a look at the best projects on Tuesday and then have the final midterm on Thursday.